Time. What is it? Where does it begin? Where does it end? Before the Big Bang, time, did it exist? Or will it ever end? When our solar system reaches the end of its life, when we no longer exist, will time still be? Is it something that flows, independent of everything, of all of us, of all space, in a straight line? According to the great fathers of classical physics, Galileo, Newton, they believed yes, time is absolute, unchanging, constant, flowing independently of everything. Especially when the term absolute time is mentioned, Newton comes to everyone's mind. But do you remember a young man working in a patent office in Bern, Switzerland? Do you know what he once wrote in his diary? Newton, I'm sorry. With this single sentence, he was kind of throwing shade at Newton, Descartes, Galileo, Maxwell, and dozens of other historical scientific giants. Gentlemen, sorry, but it's not like that, he was saying. Our rebellious youth, Albert Einstein. He was said as a student, this phenomenon or that one doesn't interest me. I just want to know God's thoughts. The rest are details. Even 1 hour before his death, he was holding his notebook and pen, trying to write the final step toward the theory of everything, to understand the mind of God. We will talk a lot about Einstein, his rights and his wrongs. All of it. I have so much to say about his life and his perspective, but today we're going to talk about time. And to understand and explain time, we first need to go back in time to the very beginning of everything. Let's go to the first time. The concept of time was studied scientifically back to 16th century. What a century that was, right? Galileo, Newton, Barrow, Descartes, stretching into the 17th century, the age of enlightenment. Then came Isaac Barrow and Isaac Newton, who almost finalized the concept that would be accepted for centuries. To all these scientists, time was, as we mentioned earlier, absolute and universal. This notion was even called Newtonian time. It was a concept of time that was the same for everyone, constant in every corner of the universe, measurable but unperceivable. Newton especially believed that time and space were separate. Even if everything in the universe disappeared, time would still exist in its own. What did Shakespeare say? All the world is a stage. And to Newton, time was the one unchanging thing on the stage. Even while explaining gravity and the laws of motion that revolutionized the world, time was the one element he left untouched. But there was a problem that Newton couldn't solve during his lifetime, a problem he thought might be the work of God, something we could never fully understand. The clearest sign of this problem was hidden in the motion of Mercury, the planet in our solar system. Newton's laws could calculate everything from the fall of an apple to the orbit of Earth. But Mercury refused to behave. It always had a deviation in its orbit. This must be God's doing, he said. Some scientists try to explain this by hypothesizing a new planet we couldn't see, Vulcan, which could be affecting Mercury's orbit with its gravity. But it wasn't there. It just wasn't. There was no Vulcan. As long as time was assumed to be fixed, there could be no explanation. Now, I want to ask something from you. It's very hard, I know, but I want you to forget everything you know about time. Forget how time passes. Forget that it flows in a straight line. Forget the idea of living between birth and death on a straight lifetime. Forget that time is the same for everyone, independent of where you live. Forget it all, because we need to completely break this perception, because it's wrong. All of it is wrong. Who says? First, Leibniz said so. For Leibniz, there were events that happened before, after, or simultaneously. There was just a way to mentally organize these relationships. But it was Albert Einstein who would ultimately put the final word on his debate. In 1905, a year known as the miracle year in physics, Einstein published 4 groundbreaking papers, including his special theory of relativity. 10 years later, he followed this with general relativity, forever etching his name to history. Time was the biggest question that haunted Einstein, who was a Newton admirer. After seeing Maxwell's equations, Einstein becomes certain of one thing: the only constant in the universe is the speed of light. No matter where you are, how fast you move, or where you look from, it's always the same. So, something had to give, and that something was time. Let's go through an example, a doomsday scenario. The sun suddenly disappears. According to the Newton's laws of gravity, the Earth would instantly shoot out of its orbit instantly, because Newton imagined gravity as an invisible string instantly pulling two objects together. But Einstein said, no, that's impossible, cause nothing in the universe can travel faster than light, not even gravity. That's our universal speed limit. Since sunlight takes about 8 minutes to reach Earth, if the sun disappeared right now, we would have 8 minutes of normal life. After that, well, it gets ugly, but that's another story. This discovery was the one of the most important in the history of science. Einstein at just 16 and came up with a famous thought experiment. He imagined a train moving at a very high speed, with one person inside and one watching from the outside. He also imagined two trees, 100 meters apart, getting stuck by the lightning at the same moment. To the person standing still, both strikes happen at the same time, but to the person inside the speeding train, they wouldn't. One would appear to strike before the other. Same event, two people, two different times. That's relativity. Light travels at exactly 299,792,458 meters per second. Let's say 300 million. For simplicity, you are still or moving. The light of speed never changes. It always exactly the same. How? Let's try to explain. You know this equation. Energy equals mass multiply speed of light square. Einstein originally wrote it as m equals E divides c square, meaning energy and mass are interchangeable. So everything you see, everything you touch is actually energy. You are made of energy and all of it. As an object's speed increases, so does its energy and therefore its mass. The closer it gets to light speed, the more infinite energy it would need. That's why nothing can surpass it. Now here is what really bends our mind. We are used to the formula speed multiply time equals distance. But when you plug in the speed of light, that formula breaks. It doesn't work the same way anymore. Let's wrap up with one final example. Imagine twin astronauts, Brian and Ellie. They are both 30 years old. Brian stays on Earth. Ellie gets in a spaceship traveling at 99.997% the speed of light for 1 year. When she returns, she is 31, but Brian, he is 81. Time moved drastically slower for the Ellie. Everything we just discussed, that was just a brief summary of special relativity. We haven't even touched general relativity or quantum physics, which even Einstein struggled with. That's just the beginning. And yes, something you might ask, what does this even mean for my life? Even I've wondered that sometimes. It all seems too hard to grasp, but then I find myself thinking about the universe, about the energy we just talked about how we are made of it, how time is just an illusion, how everything, our problems, our perspective, our goals, everything is relative. And then I realize physics actually tells me about myself. It changed how I see everything: life, the universe, society, politics, the mind, my own existence. It changed everything. So we will meet in the next video again. Until then, take good care of yourself. And as always, I'm glad you are here.